Broken hearts that you collect. Got more ice on you than Tiffany's. Reputations to protect. But I got a stick on my neck. If they were shoveling any dirt on your name, I hope that you do the same. I know it's over, but the feeling remains. Shit, I can help it, man. I always been a...
Well, hey everybody, I want to go over a test. Test number 2 for a statistics class. Let's check it out. Alright, so question number 1. It says, in a certain game, the probability that a player is dealt a particular hand is 0.41. Explain what this probability means. If you play this card game 100 times, will you be dealt this hand exactly 41 times? Why or why not? Alright, let's see. Well, we're not going to be exactly 41 times. That's not what a probability means. It's approximately, okay? So, if the probability of you getting a particular hand is 0.41, that means in the long run you're gonna get around 41 hands out of 100. So let's see which one has that. The probability 0.41 means that exactly 41 out of 100 dealt hands will be that particular hand. That says exactly, so let's skip that one. This one says approximately, this one says exactly, this one says approximately, so it's gonna be this one or this one, right? Well, let's see this one. It says let's see, the probability 0.41 means that approximately 41 of 100 dealt hands will be that particular hand. And then it says no. What is this no? Explain what this probability. If you play this card game 100 times, will you be dealt this hand exactly 41 times? No, you will not. You will not be dealt this hand exactly 41 times, since the probability refers to what is expected in the long term, not short term. That's good. That's the answer. This one says no, refers to what is expected in the short term, not long term. That's not good. So we're going to go with this one. Alright, and then we're going to go to this part and say, let's see, get the data set from chapter 5. Number 53 on NFL players. Find the probability that someone weighs at least 300 pounds. Also explain how you got the answer. You can also insert any StatCrunch images that you used. Alright, let's go to chapter 5, number 53. And let's see what happens. Okay, so data set from your textbook. Chapter 5, number 53, there it is. And we're gonna get the weights, I believe, and we're gonna find something with those weights. Well, what was it? Find the probability that someone weighs at least 300 pounds. Explain how you got the answer. Okay, insert an image if you have to. Cool. Alright, how are we gonna find the probability that someone is 300 pounds or more? We have all this data. Here's the weight, right? So how are we gonna find 300 or more? There's so many different ways to do this. What I want to do is the following. So I want to, there's so many ways. Let me bin this data. I'm going to use fixed bins. I'm going to start at 100 and then just have a bin width of 100. I'm going to click weight. I'm curious to see how people do this question because there's so many different ways to do it. But I'm binning the data in groups of 100. I need all the weights that are above 300 or at least 300, right? So let's go ahead and make a frequency distribution, and it'll count how many are greater than 300. So let's do that with tables, frequency. We'll just take the bin weights. We just need a frequency distribution. Actually, since it wants a percent, we could insert the relative frequencies also, right? It wants a percentage. So what do we have? It looks like nobody weighs more than 400 pounds. And alright, so 20%, 50, 58, and 22. That's sort of the breakdown of the weights for NFL players who are between 100 and 200 pounds, 200 to 300, 300 to 400. So I don't know, I'm curious to see how people did this question. That's one way to do it, is to create a frequency distribution like that and just say that the answer is 22%. So just show your work, you can maybe insert this picture. Say new. Grab this. And then, what do we have to do? Do we have to save that? Well, yeah, insert the picture. I'm not going to insert it right now for this video necessarily. Maybe I should. I'm going to say file, save as. Maybe I will save it. Say number 2. And then when I go to, that way I can kind of show you how this works. When I go here to embed an image, I go to Canvas, My Files, and I upload a file. And what was it? Number 2 right here. Yeah, maybe I'll just show you how to do this, so you would know how to do a test. Sometimes you need to input something like that. So I'm going to say, okay, so make sure you don't just input that. Like, if you just input that, then I don't even know what your answer is. Explain how you got the answer. Well, someone weighs at least 300 pounds. So I'm going to say, okay, the probability that someone, or let's say weight is greater than or equal to 300 equals to 0.22. Do they say what to round to? They don't say what to round to, so just say, but they ask for find the probability, so I'm just gonna say whatever, 2.2201. Let's say whatever you want to round to. It doesn't really specify, so that's good right there. That would suffice as the answer. Okay. All right. So I would say that I don't really like follow football much, but I would say I really follow, my favorite sport would be basketball and baseball, and my teams are the Giants for baseball and the Lakers for basketball. That's what I like. Alright, anyway, number 3, what proportion of people would pick chocolate if you had this two-way table? Okay, so chocolate, in the test it said what proportion of students would pick chocolate. These are all students, so children, teens, adults, everybody's a student for this one, but that was a little bit unclear. That's why I changed it to what proportion of people would pick chocolate. And to get that, notice it's just 107 divided by the grand total, which we don't know. We have to add these 3 numbers. So let me see. Let me go over here and close this. Go over here and just say, let me insert the text. Hold on. Alt Control N X. There we go. We got a text box. That's what I want. Alright, let me grab that text box. Alright, so here we go. Oh, you know what? This might be nice. Do this with my text box and just say number 3. And let me make this bigger. Change the font. What's a good font so everybody can see? Number 3, I'm going to say, well, let's see. The total sum equals to 107 plus 92 plus 70, right? Which equals what? Do I really want to add it? Do I really want to calculate right now? Not really. 107 plus 92 plus 70. When you're making a key, you don't really do things so quickly in your head. 269. You gotta be a little careful. So that looks right. Make sure I plug that in correctly. 107 plus 92 plus 70. 107 plus 92 plus 70 is good. Alright, so I'm happy with that. So I'm gonna say probability of chocolate equals to 107 divided by 269. Alright, that's how I get it. So I'm just gonna go over here and I want this text size to be bigger. Hold on. So when I plug it in, I want you guys to be able to see it. So let me kind of make things bigger. And then let me make this smaller. I want you guys to be able to see stuff. Change my font. Let's see, equals 107 divided by 269. There we go, 0.4 is that? Let me see. Okay, there we go. Round to 3 decimal places. 0.398. 0.398. That's approximately. That is approximately. So I'll just say dot 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 so you know that it's approximately. But as far as this, I'm just gonna put 0.398. There you go. Alright, number 4. It says if you randomly selected someone, what is the probability that they are a teen or would pick vanilla? A teen or would pick vanilla. Let's see. Alright. This is an OR question. It's the addition rule. You can use the formula, which I don't recommend, or you could just do it intuitively, which I do recommend. So I'm gonna do it intuitively. So number 4, I'm going to say probability of what? Teen. Or you could practice this sort of notation, and if you wrote this notation in the test, well, actually on this question you can't write the notation on the test because it's a numerical answer. Since this bar is little like this, that means it's a numerical answer, so you're not allowed to like show your work on this one. But if you were, you would want to do this notation with the P, teen, or vanilla, and whatnot. Alright, so I'm going to do it intuitively. What I'm going to do is add teen and vanilla, but don't double count. That's the key. Do not double count. So I'm going to add all these numbers, 12, 16, 45. Those are all the teenagers. And then I'm going to add that with the vanilla, which is 92, but I need to subtract the 16. See that? So one way to do that is to just do it like this. 92 plus, this is the easiest way to do it. 92 is all the vanilla, and then we just have 12 and 45. 45 and 12. So plus 12 plus 45. See that? That's for the numerator. And then let's see how this works. How's this gonna look? Divided by what? We have the grand total. We found it was 269, right? So let me bring this down, maybe make it look a little bit better. I'll even bring down the equal sign. So there you go. That's how I do it. That's the easiest way to do it. Just count it up. Count it up, 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 and divide by n, 269. So 92 plus 12 plus 45. You see how I counted that up? So this is going to be equal to, and I'll go over here, equals, okay, what happened to my font size? That's not good. I'll go up here. Equals, parentheses, 92 plus 12 plus 45 divided by 269. Alright, so I'm getting, what are we rounding to? 3 decimal places, so I'm going to put 0.554, right? 0.554. Cool. Control C, Control V, and I'm going to go here and say, right click and just change this font to whatever. What was that font again? I don't know, 24? Now I should be good on the font. Alright, let's see what's going on. 5. The accompanying data represent the number of cases of COVID-19 for individuals in the United States that interact in social settings X times per week. Construct a discrete probability distribution for the random variable X. So we basically need to divide, right? You have all these cases. We need to find the sum and then divide 200 divided by that sum. So let's see how we can do that. This is our frequency distribution. Let's copy this. Let's see if we can figure that out on StatCrunch. Do I need to sign in? Let's see. Sign in. I mean, you could probably just do this the long way if you don't really know how to do it, but it's like an efficient way. But we just need to find the sum. Oh, you know what? I know a way to do it. I'm going to call this this is gonna be my, this is gonna be like my P of X, my probabilities, and this is gonna be over here. It's just gonna be my X. So I'm gonna show you one way to do this. I don't know how students did this on the test. There's a lot of different ways to do it, but I'm gonna do it using the calculator. I'm gonna take a row. What's my row? X, right? Oh, actually, let's call this like frequency. Frequency. So then I want to do this. I'm gonna just say frequency divided by sum of frequency. See that? I'm just gonna divide each frequency by the sum of the frequencies. See that? Do I have to press build first? Or no? Okay, press compute. Close this and boom, voila. There's there's the relative frequencies. That's basically going to be our probability distribution. So I'm going to move this, Control C, Control V. I'm going to change this to X, change this to P of X. And then that will make my picture a little nicer when I insert it as my answer. New, hold on. And why did that do that? Okay, there we go. Gonna new, take this to insert for my work. Show you how to do that again. You press File, Save As. I'm gonna call this prob dist. I'm just gonna say, yeah, prob dist 2222, just in case there's another one in there. And then I will go to the test. Here's the test, and I will click this button, Embed Image. So I click that button, I go to Canvas, click My Files, upload a file, prob dist 2222, go to the bottom, press Update. So there it is. That's the prob dist probability distribution that was construct a discrete probability distribution for the random variable x. Okay, there's our probability distribution. It's a discrete probability distribution. There you go. That's how you do that. Alright. This says the accompanying data represents, same thing, right? Same question. Find the mean number of the random variable x. So there's two ways to do this question, the easy way and a hard way. The easy way, well, let's see. Well, first of all, let me 5, let's just say graph. 6, I'm gonna say, let's say hard way. Hard way is to custom calculator, which is, you should know that way. So I'll show it. So I want to find the mean of this grouped data. So I'm gonna go to StatCrunch and I'm going to do stat calculator custom. See that? Stat calculator custom calculator. And this is kind of like a weighted mean, right? So what did I have here? I had x and px, right? X is the same thing, so I have them twice, and then the weights are just basically the p of x. See that? And that's a good way to do it. There's your mean. So that's, I would call that like a hard way to do it. If can I copy this or no? Yeah, I mean, okay, so that's cool. I'm curious if people did that for their answer. So I'm gonna say control, oops. Hold on. So control C, I don't know, control V, you can put that there, or you can put that into the test. I'm not going to insert that in the test because I have to save it and stuff like that. But I'll save it here as my work, as the hard way. So for the hard way, I can do that. Now for the easy way, if I go down here, I'm going to say just n times p. N times p. That's how you find the mean of a. Is this binomial? Hold on. Let me see. What is this question? Maybe there is no easy way if this is not a binomial distribution. Actually, I take that back. There's no easy way. This is not a binomial distribution. So I was going to say just do n times p. That's for a binomial distribution. So, okay, so you have to do it that way. That is the way you do it. Is this a numerical question? Okay, cool. So I'm going to put 2.814 or 2.8. Let's see, 2.881. I don't know. What are we rounding to? And did I round that correctly? Let's see. Hundredths place. Round to the hundredths place. So 2.81, that works. 2.81 right there. Alright. Number 7. The accompanying data represents the number of cases. Is this the same question? Find the standard deviation of the random variable x. Same question. Okay. Then we have the answer. 1.71. 1.71. There you go. That's done. Both of those questions done, right? There you go. Find the standard deviation of the random variable x. Yeah, because we created the probability distribution, so that works. Alright. What else? Number 8. Show your work. I guess this is 6 and 7. So So 9. For number 9, we have the notorious roulette question. I wonder if this is the hardest question on the test. I wonder if people think that, maybe. I don't like how it's printing out. Why is it printing out like that? Oops. Meant to grab that part. Oh, that. It's printing out like that because I'm making it smaller, I see. Alright, sorry about that. The way it's printed. Let me see if I can make it look better. It's a little better. That's better. Okay. Show your work for full credit. You could insert a graph if that helps. In the game of roulette, a player can place a $5 bet on the number 29. By the way, you know, roulette, I never had any luck in it. My 2 games are like blackjack and craps. I would say if I gamble, I don't like gambling, but I used to kind of be addicted to like craps. I always wanted to go play craps. They had this bubble craps in Vegas, and I won like, I don't know, a couple, like 406. Actually, I think I played bubble craps. I won some money last time I was there. It's a bad addiction, gambling. I don't recommend it, but bubble craps, basically craps. I kind of like playing craps. I like thinking about the different strategies of how to do your betting and stuff like that. So yeah, craps, y'all. Craps and blackjack. Okay, let's see. Back to this gambling problem. Number 9. Wait, is this number 9 or 8? Let's see. 6, 7. Wow. What happened to 8? 7, 8, 9. I guess 7, 8, 8. But now we're back to 8. Alright. Here we go. How do you do this notorious question? So let's see. You could insert a graph if that helps. Alright, in the game of roulette, a player can place a $5 bet on the number 29 and have a 1/38 probability of winning. If the metal ball lands on 29, the player gets to keep the $5 paid to play the game, and the player is awarded an additional 175. Otherwise, the player is awarded nothing and the casino takes the $5. What is the expected value of the game to the player? Round to the nearest cent. Alright, let's see. Alright, so I'm going to define x as equal to the value of the bets. You could also think of it as the profits of the bets. And notice that that can be equal to things. That can be equal to -5, right? If you lose. Or it can be equal to 3, what is it? 175? Here's the hard part though. Why am I getting those two numbers, -5 and 175? There's various ways to do this question. This is only one way. Well, I'm saying I'm going to lose $5 if you think of profit. I just lost $5, so my profit is -5. If I win, here's the very hard part. I'm winning 175, and the big mistake is that people want to add the $5 and say that this is 180. But why is 180 wrong? Well, you're not profiting the $5 when you win that bet. Yes, you are getting the $5 back, but you need to remember that that was your $5, so you did not profit that $5. The only thing you profited was the 175. So that's one thing that makes this problem hard. And now, let's proceed. From here, what we can do is make the chart. So a chart like this, -5, 175, and then up here, what are the probabilities of winning and losing? So let's see, -5 would be losing, so that would be 37/38, right? I put 28, didn't I? Equals 37/38. And if the probability of winning is equal to 1/38, see that? 0.03, so that is important. That's our probability distribution. This is x and p of x. That's our probability distribution. So from that, I wonder if I can copy this in here. No, it didn't like it. want to just save it in my notes. But how would I do that? Can I Control C, come in here and paste it here? It's probably not gonna like it. It doesn't like it. Well, that's kind of unfortunate. Oh. Kind of lame. No. Hey, where'd it go? It's not wanting to paste onto this. Control V, there it is. It's pasting like that. Hey, got it. Alright, so there you go. That's our kind of showing a little bit of work on this question. So I've shown work by saying that that is the random variable. Then I showed work by inserting a probability distribution. So, I mean, if you really wanted to, in your answer, you can just go like this and just say x for, you know, when you're taking the test, you can say x p of x. Oops, Control Z, undo that, and then just say like -5. 0.97, 175, 0.03. You could do that for your test if you want to show that table like that. Well, that's nice. You can do that. Cool. So yeah, when you're taking the test, just do that if you want. Lastly, we need to find the answer, the mean, the expected value of the game to the player equals to, this is all from the player's perspective because the player loses $5. If this was from the house's perspective, then that 5 would be positive because they'd be gaining $5. Sorry, I'm turning this fan on. Yeah, if it was from the house's perspective, they'd be gaining $5 value. There we go. So then, anyways, final answer is -5, 0.97 plus 175, 0.03, and yeah, do that over here. Equals -5 times 0.97 plus 175 times 0.03. Boom, there's my expected value. Is that rounding or is that exact? I guess that's exact. 0.4 is exact, so 0.4, 40 cents. The expected value of the bet is 40 cents, is that right? Seems kind of wrong. -$5, positive 175. Is this rounded? I wonder. I don't like that that's rounded actually. Yeah, that's a little bit of a problem. But still, kind of want to change this. So watch, this is what I'm going to do. I don't like this 97 and 0.03. That's an approximation. I don't really like it. But look, I'm going to do this. -5. I'm going to say equals -5. I'm going to say 37 over 38. Is that the probability of losing? 37 over 38. It says the 1 over 38 probability of winning, so then 37 over 38 has to be the probability of losing. So we're going to lose 37 over 38, and then I'm going to say plus 175. I'm going to say 1 over 38. So now I'm more exact. I'm using the fractions. You see that? We found a typo. What's the typo? I don't see a typo. -5 times 37 over 38 plus 175. Do you want to accept this correction? Sure, I'll accept it. So that, wow, I must have plugged something in wrong because this is giving me a more correct answer. And that was suspicious about that 0.4 because we should be losing them. We should be losing. The house never wins, or the house always wins. 0.26. What do we round it to? 263. So we want to round like that. So that's your answer. So I'm realizing that if you use decimals here, you're pretty much gonna have a different answer. It may be slightly off, but if I redo that, if I redo this question and escape. If I redo this and I go in here and I plug in 0.97, how much am I gonna be off? 0.03. Weird. Wait, something's not right. I must have rounded wrong with 97. What's 37 over 38? Huh. 1 over 38. Wow. Rounding really is making a huge difference here. That's crazy. So, geez. Oh my goodness. People are gonna be getting this answer wrong if they don't leave the exact answer like I did here. Where did I leave the exact answer? Yeah, basically you gotta keep the fractions here. You're gonna get the wrong answer. See, 37 over 38. Dang. Now if I plug this in where I leave more precision, I say 0.97, let's say 4. I leave more precision. I go to the thousands place on this. And this I say 0.26. That's better. See? It's going negative. It can't be positive. Wow. This is a perfect example of how rounding wrong could lead you very astray. If you round this to the hundredths place, you are getting a positive expected value for the better. That's a gross error right there. So this is a bad probability distribution right here. This is horrible. I gotta leave more precision here. I gotta leave it like this at least. You know, really I shouldn't even leave a decimal. I gotta say 37 over 38 and 1 over 38. That's a very good example. January, great, thank you. Format, see, let's call it text. Hate when it does that. 1 over 38. Likes to translate everything. Ignore. Alright, so that, you gotta leave the exact answer. This is crazy. You're getting the wrong answer. No. Oops. Click off of that so it doesn't, that box is not selected. No. Grab this. And I will come up here, press Control V, paste right over it. Hope it replaced it. Well, there you go. You gotta leave the exact answers here or you're gonna get a really wrong answer here. Alright. Very interesting. Now let's see. What is the expected value of the game? Expected value is negative 0.263. Round to the nearest cent, negative 0.26. Negative 26 cents. So the interpretation of that is to say, on average, people who place this bet lose 26 cents per bet. On average, people who place this bet lose 26 cents per bet. That's a long term. Note that this is a long term result and it doesn't apply to a small amount of bets, because obviously if you bet once you're not going to lose 26 cents, right? If you make this bet one time, you're not losing 26 cents. You're either losing $5 or winning 175. So, alright. That was tough. Number 9. I don't need this anymore. Number 9. Show all your work. Justify your answer. A poll reported 62% of adults were satisfied with the job major airlines were doing. Suppose 25 adults are selected at random, and the number who are satisfied is recorded. Would it be unusual to find more than 22 who are satisfied with the job the major airlines were doing? Okay. Alright. Well, Yeah, I used to fly Spirit a lot because it was the cheapest airline. I used to fly Spirit a lot. I would go to Chicago for chess tournaments, playing the Chicago Open. That was fun. But yeah, I flew Spirit, FYI. Alright, anyway, shout out to Spirit. Got the low prices. Show all your work, justify your answer. Okay, what's going on here? It's asking, would it be unusual? A lot of things going on here. Unusual means probability less than 0.05. That's one little small thing. Another thing, what else? What else going on here? Let's see, it's binomial. It's binomial. We have n equals to what? What is n equal to? 25 adults are selected at random. Would have been usual to find more than 22 who are satisfied with the job of the major airlines. So 25 adults are selected at random. N equals 25. We got P. P equals to 0.62. What is everything? What's the random variable here defined as? X equals to number of people what? Satisfied? Satisfied with airlines? Is that what we're dealing with here? What are we talking about? Poll. 62% of adults were satisfied with the job major airlines were doing. Okay, satisfied. That's the probability, 0.62. It has to do with satisfied. What are we looking for? Would it be unusual to find more than 22? More than 22 who are satisfied. Okay, so this is what we're looking for then. We're looking for the probability that X is what? More than 22? More than 22. Or greater than or equal to 23. However you want to do that. You want to use greater than or you want to use greater than or equal to. You can do that, either one of those. Greater than or equal to 23. Because if it's more than 22, then it's at least 23. Because this is discrete. And that's it. That's all we're doing. Oh my gosh, the quiz will be submitted in 5 minutes. Oh my gosh. Thank you so much. Nah, I'm just trying to take this quiz so I can... Wow. Alright. It's gonna cut me off. That sucks. I'll just come back in. Redo it, I guess. And I'll start off in wherever I am, number 9. Okay, satisfied with the job the major airlines are doing. Alright, well, it's binomial. Alright, it's binomial. Muy importante to saber que está binomial. How do I get yellow, man? How do I get yellow? Huh. Say it like Microsoft Word. It's kind of lame. I have to highlight it. It's binomial. Let me make this highlighter a little bit bigger right now. Okay, there we go, it's better. Let me go to select. Alright, now, since it's binomial and it's greater than or equal to 23, okay, we got everything we need. We got N, P, we got everything. Let's go to StatCrunch. Calculator, binomial. See that? Stat calculator, binomial. We're gonna just go to N is what, 25? P is 0.62. And we're gonna be going what? Greater than or equal to 23, and that's it. That's all you do. That is all you do. So there's your answer. Control C equals to Control V. Boom. If I go back to the test, let's see. What is it saying? Oh, this is an essay question, so you would basically throw all this stuff in, you know? Control C, Control V. Boom. That's what you would do. Did it ask to round or no? It didn't say what to round to? Okay, so we're good. We can move on. Number 10, the following is a binomial random variable, true or false. A talent scout interviews people until he finds 10 candidates for a second interview. We're going to say true or false. The following is a binomial random variable. No, it is not binomial. We're going to say why right here. On the test, you don't have to say why. I'm just going to write it for you guys. Not a fixed number of trials. Problem is, there's no n. It seems like there's an n. It's tricky though. It seems like there's an n because it says 10, right? It seems like n is 10, but we need to. It's not. That's how many candidates he needs or she needs. The talent scout. They need 10 candidates. They could interview 200 candidates, right? If it's a very competitive job, like some of the jobs that I've gone for, you know, it could be like 100 candidates or something like that. So anyways, they could interview 10 people and they like them all, or they could interview 100 and only like 10 of them, or they can interview 1,000 and to get 10, and they could be very, very picky. So there you go. It could be like you're trying out for a basketball team, the NBA. That's like 1 in a million. All right, number 11. The following is a binomial random variable, true or false. A pollster calls 100 people in the US and asks them if they support increasing taxes. Yep. That one's nothing reasonable, nothing to doubt it, you know? There's a fixed number of trials, and that's pretty much it. There's no probability, but I mean, there's nothing there that's gonna cause us to doubt it. So we're gonna say true. Oh, 1 minute. All right, 12. So I guess I'll say yes. It's a true or false, so no explanation needed. 12. Show your work. You can upload a pic for this one. The time required for an automotive center to complete an oil change service on an automobile approximately follows a normal distribution with a mean of 17 minutes and a standard deviation of 3.1 minutes. I'm gonna get kicked off of this test in like 10 seconds, but we got a normal distribution here, ladies and gentlemen. We got a normal distribution. All right, we got a mean. I'm gonna just write this down. It's normal. We got a mean of 17. We got a standard deviation of what? 3.1. All right, that's our random variable x. X is approximately normal with mean 17, standard deviation 3.1. What is x? It's the oil change time. Oil change time. Oh, whatever. Let's see. Okay, fine. Let's see what happens. Let's see. Why did I do that? Let's go to preview again. I wasn't even taking the test. I'm just previewing it. Let me see. Can I preview it? What's going on? How do I retake the test? Not preview? Alright. Cool. Where was I? 12? 9, 10, 11, 12. Alright, here we are. Okay. Let's see. We've got an oil change time, I think. Oil change service on an automobile approximately. Okay. Got it. So there's an oil change time. By the way, I think I did this video before. Just like another question I did earlier with roulette. I think I have a video on that too, but I think I have a video on this one too. But let's see. The automotive center guarantees customers that the service will take no longer than 22 minutes. If it does take longer, the customer receives the service for half price. What proportion of customers feel like? Okay, these two questions are related. I'm thinking, sorry about that, but if it takes longer than 22 minutes, the customer receives the service for half price. What proportion of customers receive the service for half price? So they receive the, so it's half price if what? If X is what? Oh, that's interesting that it says no longer. If it takes no longer than 22 minutes. They guarantee that the service will take no longer than 22 minutes. Basically, it won't take longer than 22 minutes. So basically, they're guaranteeing that it's less than or equal to 22. So it's half price if it's greater than 22. So what we're looking for is that what proportion of customers receive the service for half price. So we're looking for the probability that X is greater than 22. That's what we're looking for. By the way, in this, since it's continuous, that's equal to the probability that it's X greater than or equal to 22. Those are the same thing in a continuous random variable. Those probabilities are equal. Okay, so it's half price if it takes longer than 22 minutes. Everybody with me here? Got the mean, it's normally distributed, so we're about ready to go to StatCrunch and find the answer. We're just looking for the probability that X is greater than or equal to 22 minutes, right? Everything seemed fine, so let's do it. So we're gonna go to StatCrunch, and we're gonna close this binomial one, go to another calculator, but this time normal. So stat calculator normal, and we're going to do standard, which it's already on. Plug in the mean 17, standard deviation 3.1. We're gonna go greater than or equal to 22, and that's it. There's your answer. Control C equal to Control E. Boom. Yeah, that's it. That's the answer. I guess we could do this. Control C. Plug it in. Is this a different test though? Yeah, it's a different test. It makes no sense because I completed the test before. Alright, number 13. 13. Show your work. You can upload a pic for this one. Oh, did I do a pic? I guess I could have uploaded a pic on this one too, right? Or not, if you don't want to upload a pic. Well, yeah, you probably should upload a pic to show your work on that one, because so you're definitely going to want to upload this pic. You know, you're going to want to say, let's see. Why won't it let me copy it right now? This is a graph. It should let me copy this. But for some reason it's not. But you're going to want to insert this. This is like you showing your work, right? For how you got that probability. Okay, number 13. Alright, show your work. Okay, the time required for an automotive. This is the same thing. Oil change service is normally distributed. Okay, here's the question. If the automotive center does not want to give the discount to more than 2% of its customers, how long should it make the guaranteed time limit? So basically we're going to tinker with this 22 minutes. We want to change the 22 minutes, right? Because we see here that, notice this, that we made it 22 minutes, right? We're guaranteeing that it won't take longer than 22 minutes, but that guarantee means that 5.3% of people are going to have to get the what? Is it half price? Yeah, I think so. Where does it say? Does it say half price or something? Yeah, half price if it takes longer than 22 minutes. So we don't want 5% of people to get that half price, right? Because we're losing a little bit of money there. So we're like, you know what? Let's only make 2% of people get that discount. So basically we're saying like this, right? Control C. Oh no, why? 1 second. What are we at? 24 or something? Or 28. So we want this question mark right here, basically, and we want this to be a 2. Oops. 2. That's what we want. See that? We have the probability, it's 2%. We just don't know the time. How long should we change the time to? Obviously this time is going to be bigger than what? 22? It's going to be bigger than 22. See that? Yeah. Alright, let's go to StatCrunch. Simple fair. Go to normal. Why did it not keep it for us? Maybe it did. Normal. Which one was it? 5. Hey, that's the one I just opened. Hey, come on. That one. Alright, cool. We got everything in there. Look at that. I'm going to, what am I going to do? I'm going to change this to 0.02. Look, it automatically changed this number. See that? It changes to 0.02. So look, we got it. We got our answer. The question mark equals to 23 point, well, you know what? Why am I not pasting it? But let's say 367. 367. It probably tells what to round to. It probably says what to round to. 4 decimal places. 3666. 3666. There you have it. That's it. You know, of course you want to insert this picture if you're taking the test. Then insert this picture as your work. And that's it. Next one. 14. Okay. Number 14. It's a long test. Okay, the lengths of a particular animal's pregnancies are approximately normally distributed with mean mu equals to 254 days and standard deviation 88 days. What is the probability that randomly selected pregnancy lasts no more than 242 days? Okay, let's see, how do we do this? Approximately normally distributed probability that randomly no more than. Ooh, this is tough because of the no more than, right? What is no more than? I always struggle with that. A lot of people struggle with that. Some people don't. But I have to tell myself what to do. What I do is I basically say it's the opposite of more than. So more than 242, I know what that means. So then no more than means less than or equal to 242. Less than or equal to 242. So that's what I'm looking for. I'm trying to find the probability that x is what, less than or equal to 242. See that? That's what I'm trying to find. I got that x, basically it's, what is it? Normally there's a length of an animal's pregnancy, length or duration of animal pregnancy. And we know that x is approximately what, normal with mean what, 254 and 88 days with standard deviation. Oh my gosh. Alright, so that's it. I'm pretty much gonna just go plug it into the normal calculator and find the answer. So let's see. I guess we'll start from scratch. Go to normal. 254 is the mean. Close that. Standard deviation is what, 88? And we're just gonna go less than 242, and that's it. Simple, fair. There's your answer. Control C. Does it want to round? Probably. Oh, 3 decimal places. So I'm gonna change this to a 6, and then delete all this. Oh no. I don't understand how that works sometimes. Delete. Alright. 15. Gotta go faster. Taking forever. See, 0.446, yeah, 0.446. Let's see, is everything right? 254, 88, 254, 88, yeah, 242. No more than 242. Okay, good. 15. Check to see, is this it? Yay, almost done, 2 more. 15. Check to see if the following grades could reasonably have come from a normal distribution. Give an answer to support your answer. Cool. So we're gonna grab this data and assess the normality with the QQ plot. So we could. How do you open up a new data set? Is that possible? Session? New data table? Hey, check that out. Beautiful. Cool. And then just press Control V. Why can you not press right click and paste? Somebody please tell me that. Somebody tells StatCrunch to have that feature. Alright, yeah, I want the feature where you can press right click and then select paste. Why does that feature not exist on StatCrunch? That feature exists everywhere. Like, if I go here, press right click, copy. I go here, I press right click, I can paste. See, I can paste. So that feature exists on every software. So why not StatCrunch? All right. Anyway, now trying to assess normality. It's easy. It's in variable 1. If you want, you can just call this x, whatever. Name it whatever you want. Or scores. Isn't it scores? I think these are like test scores. Now it's easy to assess normality. You go to graph and then QQ plot. And then you just click what you want, and I want the correlation statistic, that's important. And we're gonna click that. And we're gonna press compute, and that's it. There is your normal probability plot. The points, we're basically testing how well these points conform to this line. And based off of this statistics, 0.951, that's important. That tells you the strength of how well these points are on this line. So what do we got? We got like, we got this graph. Hopefully, oh look, it's good. I can copy it. Hey, Control V. Size of your selection. Do you want to paste anyway? Yeah, I don't know. It won't let me paste right now. Copy image, paste. There we go. Cool. Now, also something important. Let me move this way over here. Something very important is to notice that R equals to 0.951, which is probably going to be greater than the critical value, which that critical value is from the table. We're going to get that from table 6, right? That equals to what? What's that critical value? We're going to have to go to the test. And in the test, if you go all the way up here, well, we need to sample. I like what's the sample size? Well, let's see, it's 3, 6, 7, 8. There's 8 dots. I actually like saying what the sample size is when I'm writing my answer. Table value, table 6, n equals to, I don't know what I like to do here. N equals to 6. What do we say? 8, 3, 6, 7, 8. 8. N equals 8. Table 6. There we go. I'm going to put that in there. What is it? When n equals 8, it's 0.906. 0.906. Okay. So our correlation coefficient, 0.951, is big. It's bigger than the critical value. Therefore, what do we say because of that? Therefore, it is reasonable to conclude that, or to say assume or conclude. Yeah, because it's reasonable. It's reasonable that the data came from a normal distribution. There you go. So we assess the normality. We say it is normal, or there's no reason to believe it isn't. So it's basically normal. Where were we? 15. Almost done. That's the answer there. So there you go. You just put that in there. You can put this graph in there. I mean, how would we do it if... Can I grab this and just put it in there? Actually, I'm not going to do it because I got to upload the data and stuff like that. I got to upload the file, right? I don't want to upload this file in here. That's another weird thing. I can't just paste it in there from here. I need to go to a file. All right. Almost done. Almost done. Getting tired here. 16. The man's working hard for his money here. Alright, 16. Where are we? Last question. Alright. You will need to insert a picture of your probability distribution. Okay, create a binomial probability distribution or a table for the number of cancellations from 15 tickets sold given that the probability of a cancellation is 0.03. Okay. Okay, n equals 15. What do we got? I'm gonna write some things down. So it's binomial. We got n equals to 15 and p equals to 0.03. That's pretty much all I need to get my binomial probability distribution. That's all I need, n and p. So I go over here, close this. So we're gonna go to, what are we gonna do to create this? Ooh, this was hard. I remember this. This is hard because I have to do some stuff like where I go to data and I create a sequence of numbers from 0 to 15. I need to start at 0. I'm gonna go by 1. See that? Show you that again. I go to data, sequence, data, sequence. I'm creating a sequence of numbers, and that's data, right? I'm creating data. So I'm gonna start at 0 because the random variable is, what's the random variable again? The number of cancellations out of 15. So 0 people can cancel. That's why I'm starting from 0, and I gotta go all the way up to 15. Binomial random variables always start at 0, okay? And then they just go to n. And I'm gonna go by 1s, and now check this out. I've just created the numbers from 0 to 15. That's easier done on Excel, but hey, you can do it on StatCrunch too. Alright, so I'm gonna put in here, what am I putting in here? The p of x, right? And I'm gonna call this just x. Not sequence, I'm gonna call that x. I want this p of x. I'm trying to create a binomial probability distribution. Alright, so to do that, I think we, if I remember correctly, we went to compute. We're using our calculator, so that's in data, compute, expression. That's our calculator basically. And in here, what I'm gonna do is the following. I'm gonna say x. What am I gonna do? D binom, I think that's what it's called. I'll just go to builds to find it and put D. If I click here and press D, it'll take me to the D's, and there it is. but I don't know, when I click D it does that. Alright, I'm gonna double click the D binom, and then in here, ooh, I gotta remember the notation, don't I? It's probably XNP, D binom notation, great. Forgot the notation. D binom StatCrunch. D binom StatCrunch. It's XNP. I don't know if I had that correct, but it's XNP. I don't know if you can see that. Let me see. Control, increase the font for you. See that? XNP. Those are the parameters. N and P go last. X goes first. So that's it. So X is X. That's your sequence. I could have called that sequence. So X, then N, which is 15. Oops, let's go here and put 15. And then P was 0.03. 0.03. See if I have water. Alright. Excuse me. Click that. Getting tired here, my throat's parched. Hey, what happened? It didn't go in. Let me see. Where did it go? Sequence of data? No. Let me do that again for you. Data, compute, expression, D binom, I think I remember it. D binom X, comma 15, comma 0.03. And I didn't press compute. I don't need to press build. I need to press compute. There it is. I see numbers. There we go. There are the numbers. Look at these. This scientific notation. This is basically 0. These numbers down here. The highest probability is at 0. Why is the highest probability at 0? Because what's 3% of 15? It's 4.5. Interesting. And XNP. Let me double check that. It's XNP. I don't know why 63% at 0 in a binomial distribution doesn't seem right to me. 3%. I wonder if for the probability do I have to put. Let me try something. This doesn't look right to me. Let's go here. Options. 0.03. D binom X 15.03. It's interesting because on a binomial distribution, if I do a binomial calculator real quick, let's see, let's verify that this is correct. Oh yeah, 10. Let's see, 10%. Yeah, 10% of 15 is 1.5. 1% is 0.15. So this is intuitively correct because I was thinking 3% of 15 was 4.5, but 3% is only 0.45. So it's most likely to be closest to 0 because 0.45 is closest to 0, right? So the highest probability should be 0. You can verify that if you go to calculator binomial and just plug in 15, and then for the P you can put 0.03 and then let's go equals and let's put 0, press compute, and look, there it is, 63. It's our biggest probability, 633. See that? So 633. There you go. There's your answer. So if I grab this and I press Control X, go over here, press Control V, boom, and that would be my answer for showing my work, or not showing my work, but at least showing my answer. So I go new, and I come over here, and wow, I can barely get that 15. I kind of lucked out there, but come over here, press Control V. Okay, where'd it go? Control V. Down here. So there you go. If you wanted to make this smaller so that you can capture more of it, let's see if I can. Control negative. How do I decrease this font so I can get it? Okay, there we go. There we go. You can decrease the font if you need to get in there, and if you have a bigger data set and you need to capture it all. Man, I thought about giving 100 data values. Jeez, how would that fit? That really wouldn't fit, would it? Okay, anyways, looks like we are done. So thanks for watching, and I hope that helps.